Good evening, dear students. So today we shall be dealing with intensifying screens, grids, and faulty radiographs. Okay, this is in film imaging. This is also an important part. And last time I had discussed around 30 MCQs, and today we will be continuing the remaining MCQs along with these concepts. So let's start the chapter now. So intensifying screens, okay, basically for a radiograph to be valid and to be of diagnostic value, what do we need? We need a film to record the image, intensifying screens to expose the films, and a cassette to protect the screen and film. Okay, so coming to intensifying screen, how it is placed in a film along with the cassette, you can see the cross section diagram on the screen. Okay, the top left, this is the cassette, and the blue one over here, this area is the intensifying screen, and this is the film, and the same thing occurs on this side also. Okay, so what exactly are these layers which are color coded? Plastic front, pressure pad, base, reflector, phosphor layer, and reflector, base, pressure pad, and lead backing plastic pack. Okay, we shall see what each of the functions are. Okay, this is how it looks like. This is the cassette, right? So inside this, the intensifying screens are there. Okay, so what is the function? Why do we use an intensifying screen? See, less than 1% of the incident X-rays interact with the film, contributing to the latent image. So the IS, that is intensifying screen, converts the remnant radiation to light and produces the latent image. They act as an amplifier of the remnant radiation. About 30% of the X-rays striking the screens interact with the screens, producing a large number of visible light photons. The use of intensifying screen result in advantage of causing a slight blurring of the film. Most conventional radiographic cassettes have a pair of screens that sandwich the film. In this diagram, you can see it's like a, what do you say, a diagrammatic representation of how so this is the intensifying screen, and then this, okay, this is one part, one cross section. So X-ray photons are hitting over here, and then what happens? The X-ray photon and the light, the phosphor over here, they produce the illuminescence over here. See that dot over here, that is representing it. So again, so there is a much better reduction in the dosage of radiation to the patient, but it does cause a blur. So what is a screen made up of? Construction of a screen. It is made up of protective coating, phosphor, reflective layer, and a base. So this is the cross-sectional image. See, this is the protective coating. It is a cellulose compound. It prevents static electricity, physical protection, surface cleaning. Phosphor layer is this one. Reflecting layer is titanium dioxide, and base is high-grade cardboard or polyester plastic is used. This is how an intensifying screen within a cassette. This is an open cassette, okay? The two white part are the intensifying screens, okay? And then the film is placed in between this and the cassette is locked. Coating. Coating is transparent to it is resistant to radiation and damage from handling. Surface is the phosphor. The phosphor common form which was used was crystalline form of calcium tungstate. But modern screens use rare earth elements elements such as what are the number, efficiency. Light must be of to film. The reflective layer redirects the light to the film. The special dyes absorb the light photons coming at large angles. These photons would increase the large blur. Only the photons perpendicular to the film are emitted. The dye increases spatial resolution but reduces the speed. Base. It is the farthest layer from the film, that is the outermost, usually made of polyester. Their base should be rugged and moisture resistant, cannot be damaged by radiation or discoloration, and chemically inert, flexible, and free of impurities. Luminescence. The X-ray photon is absorbed by the target atom. The outer shell electron is raised to an excited state. So there are two concepts here. One is fluorescence. It is good for screens because gives off light only during stimulus. When X-ray or the photons are hitting, then the stimulus is there. Then the light is given off. What is phosphorescence? It continues to give off light even after stimulus is stopped. It causes afterglow of the screen, okay, which is actually harmful for a intensifying screen, or it is not that very positive, okay, for this. See, when this is a target atom, this one, the first one, okay, and X-ray is gone into the target atom, it is being emitted like a light photon. This is the principle of your luminescence. Okay, this is how it is. Next, image noise. Image conversion efficiency results in increased image noise. Now, what is image noise? Blurring, grainy appearance, speckled appearance of lesser diagnostic value image. Okay, it can be speckled appearance or grainy, occurs with fast screens and increased KBP. Rare earth screens increase the speed but increase the noise. Spatial resolution. Image details. Spatial resolution plus contrast resolution is the image detail. So increased speed means what? Decrease spatial resolution. When screen phosphors react with X-rays, a large number of the film is exposed than what would be exposed by radiation alone. This results in reduced spatial resolution and more blur. Now coming to grids. What exactly is a grid? The radiographic grid, they consist of a series of lead foil strips separated by X-ray transparent spacers. Exactly, if you want to know, it looks something like this. These are lead strips, the gray ones, and there is a gap over here, right? These gaps are filled by another material, okay? It was invented by Dr. Gustav Bucky in 1913 and most effective way of removing scattered radiation from large radiographic fields. So the function of the grid is to remove scattered radiation. So the interspaces of grids are filled either with aluminium or some organic compound. Okay, this is a construction of a grid, or how exactly a grid looks like. Alternating layer of lead strips and aluminium or other organic material. Okay. So basically grid is made up of lead and interspace materials include aluminium or organic. An ideal grid removes 100% of scatter radiation and radiation which passes and all from the primary radiation, but no such grid exists which is 100%. So let us have a comparison between the interspace material about the aluminium or organic. Aluminium is structurally stronger, and organic will be structurally weaker. Aluminium removes more secondary radiation. That means more image contrast is achieved. And organic removes less secondary radiation. Third one removes more primary radiation, more patient exposure with aluminium. And in organic, removes less primary radiation, so patient dosage, exposure dosage is comparatively lesser. Okay. Now, these are certain terminologies, certain formula which I have described here. So, what is a grid ratio? Height of lead strips represented by small h divided by distance between each of the lead strips, represented by capital D. So, GR is equal to H divided by D. So, higher the ratio, increased image contrast, more exposure to the patient, and more effect of grid cutoff. Now, let's see what is a grid pattern and cutoff. See, in this diagram, if you can see, the blue color which is represented is the lead foil, okay, the absorptive part over here. So height of lead foil is this, represented by the small h, and interspace distance over here, this white part, okay, that is represented by capital D. So this is your formula, h by d is the grade ratio. Next, grid pattern. Orientation of lead strips in their longitudinal axis. They can be linear and cross types. So grid ratio of cross grids will be sum of ratios of two linear grids. So grid styles, focused and parallel grids are there. Okay, this is a focused grid. Can you see this is a grid, and you can see the alternating layer of lead plus interspace material, say aluminium. Okay, this is the X-ray machine, and this is the cone, and there is a X-ray exposed. A divergent beam is there. Okay, so here what is happening? It is focused to this. Okay, and each and this is a grid in which all the things are placed parallelly, or also called as a linear grid. This is the diagram for it. Okay. Coming to grid performance. What is a grid performance? Primary transmission, Bucky factor, and contrast improvement factor. So any grid performance is analyzed by these three things. One is primary transmission. Let's see what it is. Primary transmission means measurement of the percentage of primary radiation transmitted to the through the grid. So primary transmission is calculated like this. PT is equal to intensity with grid divided by intensity without grid into 100. So this is usually 55 to 75%. Bucky factor, ratio of the grid to the transmitted radiation passing through the grid. So BF is equal to incident radiation by transmitted radiation, and it indicates the actual increase in exposure due to the grid's presence. So increased grid ratio is equal to increased Bucky factor. Typical value calculated for 3 to 6. Contrast improvement factor, ultimate test of grid's performance. So CI is equal to contrast with a grid divided by contrast without a grid. So increased grid ratio is equal to increased contrast improvement factor. Grid cutoff. So what is grid cutoff? Loss of primary radiation that occurs when the images of the lead strips are projected wider than they would be with ordinary magnification. So what are the four types of grids? You just need to know and look at the diagram and understand this. Okay. So there are four types of grids. One is focused grids used upside down, lateral decentering, distance decentering, and combined decentering. Okay. So these are focused grids. This is an X-ray film. This is a grid, and these are focused towards this. And lateral decentering, this is something in which the focus is little lateral than the center of the film. So far focus grid decentering and near focus grid decentering. Cut off at the periphery, dark center over here. Can you see this? and there is a cutoff at the periphery. It's not exposed. Grid ratio, decentering distance. Okay. And combined decentering uses both lateral and the focus. So, moving grids, invented by Dr. Hollis E. Potter in 1920, move to blur out shadows cast by lead strips. It moves 1 to 3 centimeters back and forth throughout the exposure. This is also called as the Potter bucket diaphragm. It is a movable grid. Okay, but they are expensive, and there is a considerable amount of the image quality being compromised. Okay, so coming to faulty radiographs. So, what are faulty radiographs? Because what are faulty radiographs? Faulty radiographs is something, now we have learned what is an X-ray film, what are the methods by which it is producing an image, and we have a patient, okay, and the area of interest is suppose the maxillary anteriors. For example, we are placing a radiograph along with a positioning device. We are using our knowledge about the projection geometry, the vertical and horizontal angulation, and then we are focusing the cone and shooting an X-ray. So once the X-ray is done, since we are learning about film imaging, we shall stick only to the chemical processing things. Okay, so from the time when you position the patient, the tube, the X-ray film, and you shoot an X-ray, and then go on to processing, okay, there are errors which are bound to occur, or the possible errors and the faults in the radiograph can be divided briefly into three types. One is during the projection errors, another one during exposure errors, and third one will be processing errors. So this goes stepwise, right? So first you project, then you expose, and then you process. So all three stages, faulty radiographs can be possible. So now I have added photographs for each type of the error, so you can learn with the photo so that it is very easy for you to remember. Let us go one by one on this. Okay, see, this is in White and Farrow, textbook of oral radiology, version 6, that is edition 6. This is a nice table in which they have consolidated all the different common problems in in film exposure and development. Okay, but to read it just like this, you are not going to understand very appropriately, because you also need to know how an error looks, so that tomorrow if you have a radiograph, you will be able to find out that what is the error and why it has been caused. Okay, so first, please go through the photographs along with the explanation which I will be teaching you now, and then go back to this tabular column so that it makes sense. Okay, so let's start now. See, first thing, radiopaque artifact. You're positioning a patient, okay? If he or she is wearing a specs, or a tooth jewel is there, or any metallic earrings, nose pin, and other things are there, and even a cast partial denture in the mouth, okay? Any prosthesis is given, then that time also this radiopaque artifact is possible. If you can see in this picture, okay, this is a prosthesis and this is a tooth jewel. Okay, next, blurred image. What happens when the patient moves, or the cone moves, or the X-ray film is moved? There is a blurred image. Can you see the radiolucent dot, the black dot here? This one, it is usually because of the embossed dot which is on the film packet, which helps us to do what? To identify the sites, and it is a guidance, right? So sometimes they also come as an artifact, and especially if these are placed at the apices of any then they can even radiology. This is the occlusal surface. The occlusal surface, that there is no film which is covering the periapical area. So this is the pure positioning defect. Next, surface not covered, reverse of that. The film is placed little too neatly that all the overlap of images, why these happen? Because of how it's not proper. So when already exposed film packet is exposed again. Can you see here? You can see even this over here. Seems to be, and here you can see the molars. Okay, this is you have something called as the lead foil, right? Inside the film packet. So what happens when you reverse happens can appearance over here called as herringbone appearance. This is because the film is placed reverse side. Okay. So slant occlusal surfaces. If you can see this radiograph, it looks like it is coming in an inclined plane like this. Why is that so? Because the X-ray was not placed parallel to facial, so this slant is coming. Area of if you bend it excessively, then a black line is formed. Okay. Distortion image. We have a comparison here. This is a normal image wherein all the angulation everything is proper, film positions everything is proper, film positions with the crown. Here what is happening? It is looking like there is a tilt or there is a bend in the root, or the image looks it does not look normal. So these are the distortion image. Here, if you bend the film to adjust to the anatomy of that particular area, little excessive, then distorted images do result. Then elongation. This is because of less bone loss. Because instrumentation, we need to have an approximately proper radiograph to judge the length. Okay, so this is elongation. Foreshortening is just opposite of that, wherein there is a excessive angulation, vertical angulation. Teeth appear shorter than normal. This is also very detrimental in endodontic treatment. Okay, so this is foreshortening. Then we have the most common type of radiographic fault which happens, that is the cone cut. What happens whenever there is a area of interest and you are placing a radiograph, but the cone position, the central beam is not aimed properly in the center of the focal spot, exposed only. So that is a blank image. Now these will be your processing errors. Okay, so blank image to the film at all. Okay, and simply you have put it in the developer or the fixer. This is a blank image. Okay, so dark image. This is an overdeveloped image. Okay, wherein a lot of time has been taken into the developer solution. Contrast. This is a light image. Okay, just opposite of that. Now reticulation, it has a grainy and speckled appearance which is caused due to what do you say, there are more silver bromide ions or the atoms which are there. Okay, and due to some chemical changes, and whenever you put it in the developer, this reticulation can be a possibility. Okay, so black spots. What are black spots? Whenever when the film is exposed and then you open and dip it into the developer. Prior to that, if there is a developer contamination, okay, some drops of the developer forms on the film, they appear as these black spots over here. Okay, these are the developer spots. Contrast white spots is the same problem if the film before the exposure is contaminated with the fixer droplets, then white spots are formed on the radiograph. Yellowish brown stains. Okay, yellowish brown stains means if the developer and the fixer are depleted, they are not concentrated enough. So that means it is a yellowish brown stain is formed. Crescent shaped defect or the nail defect, we call it. Can you see this? It looks like a nail mark, right? Over here. This is exactly what happens when you carelessly handle the film or you put pressure with your nail. Or even what happens normally on the radiograph, we write the tooth number for reference or the patient details sometimes. So even the pen mark also can come in this way. Okay. So developer cutoff. Whenever we are dipping a film, we are opening the packet and dipping the film in the radiographic developer. If you have not fully dipped it, this top part, can you see over here? It is cut off. Okay, it is not. It won't develop. Only the part which is down in the developer will develop. Okay, so this is a developer cutoff. Opposite to that will be a fixer cutoff. It is properly developed, but in the fixer you are not putting it properly into the solution, and a part of it remains outside or not in contact with the fixer, will result in a fixer cutoff. So fingerprint marks. Fingerprint marks, if before the developing of the film, if your hands are or if your fingers are contaminated with either of the solution, the developer solution or fixer solution, and with the same hand, if you touch the radiograph and you dip it into the solutions for developing, that comes as the fingerprint mark as an artifact. Scratched film is due to improper handling, careless handling, and all that. So static electricity branching appearance, this also happens. Okay, over here there is a branched appearance here. This is due to silver iodide crystals being exposed. Okay, so these are the faulty radiographs, how they look like, and a brief description of each. Okay, now if you go back and you can read um, the white and farrow, the one which I have attached to this, that is your the tabular form, okay, in which it is there. See this box 6.1, common problems in film exposure and development. Now, if you read this, you will know that how each thing looks like. Okay, you will be able to understand and retain it better. Okay, so now let us go to our MCQs. There are a lot of MCQs for this. Okay, I will discuss this with you. Yesterday we had done till 30, and now 31 onwards we will go about it. Okay, so MCQs basically, like I have been saying, whenever you want to answer or attempt an MCQs, basically MCQ is a pattern of exam which is testing your reasoning skill. Okay, if you are through with the concept completely, you can very easily answer these. Okay, so always read a little bit of the theory point wise and then attempt to answer these. Okay, so coming to question 31, which is the purpose of the extraoral intensifying film? The answer is C. Absorb X-rays and emit the visible light. So 31 answer will be C. 32. Which is the purpose of green dyes added to the surface of the silver halide grains? That is C. Increase light absorbing capability. 32 answer is C. 33. Which component of screen film emits visible light? Answer is B. Phosphorus. 34. If intensifying screens help to reduce patient exposure, um, which reason best explains why they are not used in intraoral imaging? The answer will be C. They reduce the resolution of the image. Okay, in big film, what happens? Even if there is a blur or there is not a proper resolution, but still the area covered will be more. But in intraoral, area itself is small, right? So they lose their diagnostic quality. So that is why 34 answer will be C. 35, which is not a part of an intensifying screen. Base is a part, phospholayer is a part, and polymetric coat is a part, but D is the option. Identification dot is on the film packet, not on a screen. Okay, so 36th question, which is a disadvantage of reflective intensifying screen base. So that is answer is C. Results in image unsharpness happens in this. So 37. Which reflecting material is applied to the intensifying screen base material? That is A. That is titanium dioxide. 38. Rare earth elements used in intensifying screens may contain all except one. Which one is the exception? Okay, that is A. Uranium is not there. Lanthanum, gadolinium, phosphorescent crystals are used. So uranium is not in picture. So answer is A for 38 question. 39th question. A pair of rare earth intensifying screens absorb approximately which amount of the photons? Okay, answer is B. 60% of photons are absorbed. 40th. Which visible light photons are used in extraoral imaging? That is A. Blue and green light. Okay. So 41st, the fluorescence of the phospholayer of intensifying screens can be increased by the addition of small amounts of all except one. Which one is the exception? Last is the cadmium. Okay, cadmium alone is not added. Thulium, terbium, and niobium are used. So 41st answer is D. 42nd, which best explains the importance of matching green emitting screens with green sensitive films and blue emitting screens with blue sensitive films. So the answer will be D. Different phosphorus fluorescence in different portions of the spectrum. Okay. 43. The speed and resolution of an intensifying screen depends on all factors except one. Which one is the exception? Phosphor grain size, yes. Phosphor per unit volume, fine. C is the answer. So it does not really depend on phosphor spectrum range. And D is also, it's the phosphor conversion large phosphor crystals. Okay, the answer is C. Results in image screen, lower the resolution of the image. Okay, so 45th, smaller sized crystals and or a decrease in the thickness of the screen results in. Okay, answer is C. That is increased image sharpness. 46th question. Debris or scratches on an intensifying screen may cause which error on the resulted radiographs? Okay, the answer is B. That is called as light spot. 47. All factors except one affect the degree of film density. Which one is the exception? Over here, it is C. Type of imaging. So film emulsion, beam intensity, composition of object, they do affect the density of the film, but type of imaging is irrespective. So 47, answer is C. So 48, after being struck by photons, the silver halide crystals in the emulsion are converted to. Answer is C. That is metallic silver. That is AG. Okay. So 49th question. The overall degree of darkening of an exposed film is referred to as radiograph. Um, B. That is density. Okay. So 50th question. Which optical density allows 100% of the light to be transmitted? Answer is A. That is 0. Okay. 51st question. Gross fog includes all except one. Which one is the exception? The answer is D. Optical film density and logarithm of corresponding exposure. 52nd question. Which action decreases the radiographic density? Okay, that is again D. Increasing the distance between focal spot and the film. And then 53. Which rule of radiation exposure applies to edentulous patients? Answer is C. That is maintain KBP, MA, and decrease the exposure time. Okay. And 54. Which natural structure has the least density? Answer is B, that is muscle. Coming to 55th question, dense objects which are strong X-ray absorbers cause the radiographic image to be. Answer is C, that is light. Okay, which dental radiology term is used to describe a dark area on the film resulting from objects with low density? 56, answer is C, that is radiolucent. Okay, or radiolucency. 57, a radiographic image with few shades of D, that is high contrast. Okay, few gray shades and more of a the radiopaque structures. Okay, radiopaque structures. And then 58th question, the subject contrast is influenced by all except one. Which one is the exception? That is B, texture. 59th question, which is an accurate description of a film exposed at 60 kVp compared to a film exposed at 100 kVp with all other factors being constant? Okay, answer will be C, that is high contrast to low contrast. So the kVp increases, the contrast is lower. So any film which is exposed at 60 kVp will have a higher contrast compared to the one at 100 kVps. Okay, so 60th, a measure of the range of exposures that can be recorded on a film as distinguishable densities is called. Okay, that is film latitude. Okay, and coming to 61st question, which is a primary cause of radiographic noise? What is the cause? Basically, there are many different causes, but in the okay, so the film is not handled properly, radiographic noise or the blurred or the speckled image is the resultant image. Okay, and then which is caused by a fluctuation in the number of photons absorbed by the fast film intensifying screen combination. That is B, that is quantum mottle. 63. All factors contribute to the blurring of image sharpness except one, which is the exception. That is B again. That is finer silver halide grains. Okay, the finer the grains, increase in the sharpness is C. Okay, and 64th, which factor results in parallax unsharpness? This is option is D, that is image magnification on a double emulsion film. So 65th question, that is D, that is reduce the density of a film except one. Which is the exception? That is B, that is metallic silver. So 65th question, which factor results in parallax unsharpness? That is B, that is metallic silver. So 67, latent image sites contain which component? Okay, latent image, that is D, neutral metallic silver atoms, that is Ag atoms are there in the latent image sites. Okay, so 68, stored radiation energy on the film is called as. Okay, the answer is B, that is latent image. 69th, which occurs when the silver bromide crystals are exposed to photons and ionized? The answer is D, silver and bromine atoms are separated when this happens. Okay, and 70th question, which converts silver bromide crystal with neutral silver atoms deposited at the latent image sites into black metallic silver grains? Option is B, develop a solution. So basically, this question says that the function of the developer is given in a sentence form. See, converting of silver bromide with neutral silver deposited at image sites into black metallic silver grain. So this is the function of a developer. So answer will be B. Okay. Coming to 71st question. Film areas where the silver halide crystals receive more radiation and are highly energized appear how on the images? Okay, that is answer is C, radiolucent images, which occurs when the developer solution reduces silver bromide halide crystals that do not contain a latent image. Okay, that is answer will be C, dark density. Okay, more radiolucent images Uh, there. Then 73. Which chemical is the first to reduce silver ions to metallic silver at the latent image site? 73 answer will be first, that is phenidone. 74th, which describes unexposed crystals during the time required for reduction of the exposed crystals. 74 option is B, unaffected. Okay. 75, which is the optimal pH value of developing solution. The one is last, that is 10. It should be more alkaline. Okay, and then 76, which component of the developing solution causes the gelatin to swell? That is the first one, the activator. Okay, which component of the developing solution extends the useful life of the solution? That is D, that is preservative. Okay, and 78th question, which is the purpose of the developing solution restrainer? Okay, what is the purpose? That is prevent the unexposed silver halide crystal development. That is D. Option for 78th question will be D. Next, 79th question, which processing component serves as an anti-fog agent and increases film contrast? Okay, that is second one, restrainer. 80th question. Situations that cause a depleted developing solution include all except one. Which one is the exception? The answer is C, production of bromide ions. Okay. And then 81st question. The recommended amount of developer replenisher is based on the average development of how many radiographs per day? Answer will be C. That is 5 panoramic radiographs. 82nd, which prevents neutralization of the fixer solution? Answer is D, that is water rinsing. Okay, which is the primary function of the fixing solution? Answer will be B, that is dissolve and remove underdeveloped or undeveloped silver halide crystals. Okay, then 84, which is the most commonly used hardening agent? That will be C, aluminium sulfate. 85, which is not a function of the hardener. Okay, which is not a function, that is D. Okay, removes undeveloped crystals. So hardener function is what? It prevents gelatin damage, lessens the water absorption, reduces emulsion swelling, but removes underdeveloped crystals? No. So 85th answer is D. 86th question. Which factor decreases the efficiency of the final washing process? Answer is D, that is temperature below 60 degrees Fahrenheit. 87th question. Remaining silver compound or thiosulfate on film causes, that is discoloration. Okay, that is B. 88. Darkroom stray light causes. What does it cause? It causes film fogging. Okay, do you remember the coin test? That is the example for it. So 88, the answer is B. 89, which is the minimal distance from the work area to mount a 15-watt safe light? Answer is B, 4 feet. Okay, at least 4 feet distance should be maintained. 90th question. Fast intraoral dental film and panoramic films are sensitive to all spectrum of light except one. Which one is the exception? Okay, the first is red. That is why the safety light is also a red colored light. 91st question. The temperature of manual processing tanks should be maintained at, they are 60 to 75 degrees Fahrenheit. Option is B. 92. The purpose of the manual processing tank cover includes all except one. Which one is the exception? That is D. Control and maintain temperature. That is not. Mainly it is covered for what? Minimize the evaporation, reduce oxidation of solutions, and protect the films from light exposure. But control and maintain temperature is not purpose of the processing tank covers. Okay, so 92 option is D. 93rd question, which is the main purpose of holding films by the edges? Okay, that is A, prevent the fingerprint artifact. Go back to the picture and recall it. Okay, so 94th question, Proper darkroom ventilation serves all of the following purposes except one. Which one is the exception? That is A. Prevents film mold. Okay. Coming to 95th question, which is not detrimental to unexposed film. The answer is C. In humidity, definitely there is a the film damage happens. Scatter radiation, yes. High temperature, yes. But low temperature, as such, does not damage the unexposed or the new films. So 95 option is C. 96, which describes the proper amount of solution in each tank. The option is C. The proportion of film. All steps except one should be implemented prior to developing films. Which one is the exception? That is what C. Rinse films to obtain to soften emulsion. That happens after that, right? So all except C is implemented prior to developing. So 97 option will be C. 98th question. Best practice includes all except one. Which one is the exception? Okay, the option is C. Hold film up to a safe light to check for fingerprints. Okay, clip one film to a clip, yes. Label the film racks with patient name and date, yes. Ensure films are completely submerged in solution, yes. But hold the film up to a safety light to check for fingerprint is not applicable here. So 98th option is C. 99. If the developer temperature is 76 degree Fahrenheit, which is the proper development time, okay, that will be B. 3 minutes. 100th question. Which can occur if film are processed in solution with excessive temperatures? What happens? There are dark density radiographs. So option is A. 101. Which is the purpose of agitating the film hanger after insertion into the solution? That is because uh, to eliminate the air bubbles, this is done. Okay, so option is B. 102. Which process slows the development of film and minimizes fixer contamination? Option is B. That is 30 second rinse is done. Immediately after the development time, it is dipped into the water for 30-second rinse. Why? Because we have to stop the process of developing, and fixer also should not be contaminated with the alkali solution because fixer is an acidic medium. So option for 102 will be B. 103rd question. The rapid drying of films results in all except one. Which one is the exception? Answer is C. Dark drying, dark film density. Okay. Rapid drying results in all except one. So uneven drying happens, drying artifacts will happen, distortion of gelatin is possible, but dark film density, no. So 103 option will be C. 104. Which chemical occurs in higher concentrations in rapid processing solutions? 104 answer is B. Hydroquinone. Okay. 105. To preserve rapidly processed films, which process should be implemented after viewing? That is C. Place in conventional fixing solution for 4 minutes and wash for 10 minutes. So 106. The incomplete clearing of unexposed silver halide crystals results in option is D. Films that turn brown with age. Okay. So 107, all processing measures except one ensure quality control in the darkroom. Which one is the exception? Exception will be B. Maintain film distance of 6 feet from safe light. Okay, so all processing measure. Check the darkroom for light leaks frequently. Yes. Prepare processing solutions according to manufacturer's directions. Yes. Expose double film packet with new solutions compared to later processed films. Correct. But maintaining a film distance of 6 feet from safe light is a wrong option because at least 4 feet gap only should be there. So 107 option will be B. 108. Which is the most important advantage of automatic film processing? Option is A. It saves time. 109, which is a disadvantage of automatic film processing? Option is D. Film quality is reduced compared to conventional processing. 110th question. The automatic processor mechanism provides all advantages except one. Which one is the exception? D. Fosters prevention of infection, cross contamination. Okay. Um, Coming to 111th question, which feature makes the automatic processor fixer solution different from the manual processing fixer solution? Answer will be C. Additional emulsion hardener is added to this fixer, which is in an automated processor. Okay. 112th question, which processing error results in light radiographs? That is A. Low temperature. Okay. Then 113, a reversed film packet in the mouth results in which type of radiograph? They will be B. It will be a light radiograph. Okay. So all except 114, all except one causes yellow or brown film stains. Which one is the exception? Okay. The answer is C. Replenished developer. Okay. Yellowish brown stains are caused by depleted fixer, insufficient washing, and contaminated solution. But a replenished fixer or a replenished developer is not supposed to cause these things. So answer for 114th question will be C. Okay. So 115. Which dental product presents as the primary environmental concern? Okay. The answer is D. Dissolved fixer silver in used fixer. Okay. And 116. Which is the main advantage of opaque film mounts? Okay. The answer is C. Obscure stray light among the around the images. Okay. For a better view, for a clear view of the images. So 117th question, which is the preferred film mounting orientation? Easy to say which side is the area of interest. Okay. So 118, which side of the duplicating film should be in contact with the film to be copied? That is B. Emulsion side should be on the duplicating film. Okay. So 119, which action corrects the process that results in a duplicating film that is too dark? Option will be A, that is increased exposure time. Okay. So for film imaging on the whole, that included your X-rays, type of radiographs, intensifying films, grids, and faulty radiographs. All the MCQs about the previous class and this class have been completed. Okay. And one small suggestion for the students, whenever you are going through the questions in this particular chapter, please refer to the notes, and even you can refer to your books also. And I have added maximum possible images for each of the falls. First, try and understand how they look like. Okay. And then please go and refer the table which I have attached with this presentation, so that you can answer your MCQs more easily. Okay. Any doubts, please reach out to me. Okay. Thank you so much. And my next topic would be on projection geometry and principles. Okay. So these basically include the different positioning and different radiographs, and based on what anatomical location and why do we do it. Okay. So this is how it projection geometry works. The cone position, patient position, and everything will be dealt with in detail. Okay. So the time will be notified to you. And thank you so much. All the best.
Okay, yeah, yes, yes, ma'am. So thank you very much. And today
Uh,
again we had that internet glitch in between.
some internet issue today also. I think now I'm able to see that one. I think he's a student or something, right? But he has left the view.
Right. Yeah.
Okay.
So no problem.
Okay.
We will get this one figured out of it.
But the voice was not coming clearly throughout, or it was just in the
Yeah, actually,
beginning?
what happened? Sometimes even your video lost, sometimes your audio lost, and even sometimes we could not see the presentation also.
Oh,
Yeah.
okay.
So, but
No, but today I have connected to an alternate internet connection because the Wi-Fi at home is definitely having some issues and all that. But today I had an alternate connection. I don't know why it doesn't seem to work, because in this way, then they will not be able to see the
right.
full
So next
presentation. No,
time,
then
what we can do, if possible, try to connect your laptop
okay,
on LAN, and we will see whether we have the same
okay.
concern on LAN also, or that is only happening in Wi-Fi connection.
Okay, fine. You just guide me on that. I will do it.
Yeah, right.
Okay. But otherwise, any major problem in the presentation or
No,
something?
no, this was just for maybe 5 or 10 minutes. We had this problem. Otherwise, rest of the
Okay.
set would, you know, went well. There was not
Okay.
nothing.
Okay. Fine.
Yeah.
So, Sam, I'll be going to my parents' place tomorrow, so I'll be there for the weekend. So, let me start this again from Tuesday evening, 8:30 onwards.
No,
By
no
that time, I
problem.
will be able to prepare for the next one.
Yeah. So whenever you are back to your place, you can text
Hmm.
me so we can start again.
Okay. Okay. Thank you so much. Yeah.
You're welcome, and thank you, ma'am. And enjoy your weekend with your
Okay.
parents. We'll see you soon.
Yes, yes, definitely. Okay, see you. Bye. Yeah, good night.
Good night.